The Fsx Cleaning Worksheet is designed to take you through a step-by-step cleaning process. It also provides documentation that can be very valuable to your customer as well as to a fleet maintenance team.
It is recommended that a worksheet be filled out for each DPF cleaned. Start by filling in the date, part number, serial number, and manufacturer. Accurate filter dimensions will be important to have if the DPF you are cleaning is not yet included on the baseline chart. You will need these dimensions when you call FSX to get an estimated baseline. Step 1 is a quick visual inspection process to sort out failed DPFs. Note on the worksheet the clean and dirty end colors and any chips, gouges, cracks, or melting. If a small chip or gouge extends past the ceramic plugs, exposing open cells, it can be repaired using the recommended ceramic repair putty found under Section 12 in your manual. If the filter has any indication it is contaminated with oil, coolant, or fuel, it is recommended to replace the filter or send to FSX for special processing at a discount. The reference data posters will assist in identifying certain problems. At this point, you want to determine if the filter is melted by pin gauging the clean side. Finding the pin gauge depth is easy when you drop the pin gauge down inside the clean side or outlet end of the DPF. The pin depth will be about 1/4 inch less than the height of the ceramic. Once you determine the pin depth, place a piece of tape around the pin at the base of the filter to save time measuring. Note the pin gauge depth above Step 1 on the worksheet. Proceed to pin the 7 locations noted on the worksheet around the DPF as if it is a clock. When the pin doesn't drop to the tape, it indicates the filter is melted. Pin around the melted area to determine the size of the melt. If the melted area is larger than the size of 1/4, the filter should be replaced. Write in the pin drop measurements on the worksheet. Once the filter is cleared to move forward, place it on the trap tester for a pre-clean test. This measurement shows how plugged the DPF is and serves as an indication on how much cleaner the filter becomes after the pneumatic cleaning. Black cells on the clean side of the filter indicate internal damage inside the DPF. Black soot on the clean side is caused by a hole or a crack in the cell wall that causes soot to bypass. We call these black holes. Circle the approximate number of black holes observed on the worksheet. It may be obvious at this point that the DPF has sustained considerable damage, but it is important to confirm the bypass during the 2-minute bypass inspection in Step 2. Black holes are not always visible during the visual inspection if the DPF went through a regeneration prior to removal or if the filter color is dark gray or black. At this time, the DPF is ready to go into the trap blaster for Stage 1 pneumatic cleaning. As soon as the trap blaster is turned on, the 2-minute bypass observation must be performed to diagnose the internal condition of the filter. Watch the top of the filter for the first 2 minutes and note approximate number of black holes or bypass on the worksheet. Black eruptions coming through the filter are a sure indication of internal damage. If the black soot was burned out of the DPF during a recent on-truck regeneration, the dust may be white or light gray. This is ash, the non-burnable metal and mineral compounds from lubricants and engine wear. If the DPF has over 20 failed cells, the machine can be shut off and it is recommended that the filter be replaced. If the filter is still good, the operator can walk away from the trap blaster until the cleaning is complete, which is typically about 25 minutes in full air mode. Clean the filter until material stops coming out or until the orange light illuminates when the timer has expired. When the material has quit discharging from the dirty end of the filter, it is time to shut the machine off and remove the DPF. At this point, it is important to pin gauge the dirty end of the filter. Use the same pin gauge with the tape mark that was used previously for the clean end. Pin gauging the dirty end of the filter determines if there is any hardened ash left behind. If there is more than 1 inch of remaining ash in the DPF, it means the DPF should have been cleaned sooner. This information is helpful for adjusting DPF maintenance schedules to prevent premature DPF failures. Ash in the DPF hardens over thousands of miles, causing higher heat, increased fuel consumption, and more regenerations. This will eventually destroy a DPF. Cleaning the DPF sooner will prevent hardened ash buildup in the filter. Pin gauging is the only effective method for measuring hardened ash content. Follow the round diagram on the worksheet as you pin gauge the 21 cells around the DPF and record the measurements. The ash content left inside the filter is an important indicator to assist in making adjustments to the DPF cleaning intervals. After pin gauging, test the DPF with the trap tester again and record the reading on the worksheet. Compare the reading to the baseline chart. If the filter is in green tag range, then the process is complete and the DPF can be reinstalled. If the reading is outside of the green tag, then continue to step 4 below for further cleaning. Whatever the case, mark the DPF status at the bottom of step 3 on the worksheet. Follow the trap burner operation procedures in the previous section. After the program has completed, remove the DPF from the trap burner. Make sure the center of the DPF has cooled to below 125 degrees Fahrenheit before placing it into the trap blaster. After thermal cleaning, 100% of the soot is completely gone from the filter. It has been oxidized into a gas. However, ash doesn't burn and may remain in the DPF, but might have been loosened during the thermal process. A second pneumatic cleaning will remove any remaining ash that is loosened in the trap burner. Use the flow direction arrows on the side of the DPF can to make sure the filter is placed correctly in the trap blaster. Process time is usually much shorter than the first pneumatic cleaning. When the ash stops discharging from the DPF, shut the machine down and pull the filter out. Circle the time on the worksheet and record the last trap tester reading. Pin gauge the filter one last time and record the results under After Thermal Step 3. Assign the DPF a final color code classification based on the airflow, either green, orange, or red. Write any final comments and sign the worksheet. These worksheets should be kept on file or in a 3-ring binder for future reference. If cleaning for customers, they like receiving a copy of this worksheet with each DPF. Make sure to explain the form and how the hardened ash content will indicate if they are cleaning their DPF soon enough.